Hello, YouTube. All right. Connection today was easier. Hello, I'm Greg from GregsTutoringNYC at gmail.com. If you'd like to contact me, my email address is in the little description there. So again, we're going to continue on with some of the examples I've been using for the past 2 days, which I'm calling SHSAT-like examples. They're from the ISEE, the Independent School Entrance Exam, which a lot of kids take for private schools. It's also used for the Boston exam schools, like Boston Latin, which is the Boston equivalent of the New York City specialized high schools. The tests are actually kind of pretty different, but there's some similarities, and we're going to use it as the basis. And YouTube just gave me an error. It just said I had an excellent connection, and now it's saying I don't. So we're just going to continue on where I left off the last time. This is part 3, I believe, and please like the video. Please subscribe. I'm going to be doing these from now on. I've done a whole 30, 40, 50 of them already. I'm going to continue on doing that. So let me just make sure my connection is okay here. Yes, we look okay. All right, so what I'm going to do is move me out of the way. What I'm going to do is continue on from example I had yesterday. What happened was I moved the live thing that I write the answers on out of the way by hand, and then I solved this question, and it never showed up. All right, so in fact this is in the way already. Let's do something like that for now. All right, so what I'm going to do is the other YouTube showed some of the descriptions, so let me just jump into this. The issue was we had a scale factor of 2/3, and the main point was the area of the right triangle is b times h over 2. So a lot of kids, for instance, for triangle number 1, are going to do 12 times 3 over 2. They get 36 over 2 and get 18. Did I do that right? 36 over 2 and get 18. And then they're going to multiply that by 2/3, get 6 here, and get 12. Okay, but that's wrong because the 2 sides is what the 2/3 needs to be applied to. This is being squared. It's 12 times 3, and we get centimeters squared. So we need to apply the scale factor twice. In fact, if we have the triangle, and this is 12 and this is 3, we don't apply the scale factor to the area. We apply it to each of these. So what we basically need to do is get 2/3 of 12 and 2/3 of 3. Okay, so we can write that out if we go back to the b.h. So there's a couple of ways I want you to understand that to do that. So the way I was presenting was 12 times 2/3 times 3 times 2/3 over 2, and then what would we get there? I believe the answer was 8 at the time. So the main thing is to put these 2 numbers into here. All right. So I don't want to spend a lot of time on it because I think I did already. Yeah, the thing fell off the screen though. In fact, it might be even falling off the screen now. All right, so so I just wanted to make sure we cover that. And the same is going to work with the 2/3, with the 3/2. We need to apply the 3/2 twice through multiplication. All right, so let me skip to where I think we ended up. So I think we are at the least common denominator problem. Yeah, least common multiple, sorry. So a lot of kids get this confused with greatest common factor, greatest common denominator, all this other stuff. So a multiple, if I have 2, a multiple means 2 times 1 is a multiple is 2. 2 times 2 will give you 4. 2 times 3 will give you 6. So we have 2, 4, 6, 8, 10, and so on. So it could be a multiple of any number. It's the number usually times a whole number integer. Technically, we can say we have a multiple of 1.5, and we would get 3, and 1.5, and get 4.5, and then 1.5, and get something like 6.75 or something like that. So anyway, we need the least common multiple of 3 numbers, 8, 10, and 12. So this is more set up right now like a grade 7 and a grade 8 state math test, this is not really a tough ISEE problem or a tough SHSAT problem, but it's there. They also do throw things in just to make sure the kids have some of the basics down pat and that you're not forgetting some terms. Remember, we need to know terminology, we need to have math sense, and the key part of this question is not so much answering this question, but that you may need to use this for another problem. And by the way, I'm going to put a microphone on again because I have fans running here. So give me 1 second. Lowered my voice. Give me 1 second. I'm noticing the microphone is lowering my voice, but if you pump up your speaker, you should be able to hear it. At least you got my voice lower, which you can pump up, versus a fan, 2 fans counteracting on top of my voice there. So so we need to get the least common multiple, which means what number, x let's call it, is a multiple of 8, a multiple of 10, and a multiple of 12, and the smallest possible number where that could be the case. So we might find that one answer is 1,000,000, but another answer is 10,000. So 10,000 win because it's the least common one. So there's kind of 2 ways to approach this kind of example. One way is to just start writing out the multiples. Now, when you have 3 numbers, it's normally best to use the larger number first and just start writing out multiples. 36, 48, 60, 72, 84, 96, what do we get, 108? Did I do that right? 12, 24, 36, 48, 60, 72, 84, 96, 108, yes, and 120, 144. Okay, we can go on. Let me kind of half zoom this out so that this can fit on the screen. Actually, on that note, let me make sure this is fitting on the screen. So one issue with this technique is that we don't know how many of these to write. So basically, we're going to write some that just goes across the page. Leave a little space because you may have to fill in more. So we're going to try the second highest number. We get 10, 20, 30, 40, 50, 60. 60 is a match. Okay? So that's the least common multiple of these 2 numbers so far. So then what we do is we would ricochet into 8, 16, 24, 32, 40, 48, what do we get, 54, and then, wait, did I do that right? 8, 16, 24, 32, 40, 48, no, 56, and then 64. So since 64 is greater than 60, can't be it. So we're going to come back up to the 12s, to the 10, sorry, and go 70, 80, 90, 100, 110, 120. So we see now that 120 is the second next match, right? 60 didn't work because this goes into it. So I have 64, 72, 80, 88, 96. What is the next one? 112, 96, 86, and then 120. 80. I made a mistake here somewhere. 8, 16, 24, 32. And by the way, this is why these examples are good, because you have so many numbers you're throwing down here that it is easy to make a mistake. 72, 80, 88 plus 8 is 96. 96 plus 8 is what, 114? 8 here, we get 122. Wait, somehow 8 goes into 120. I know that. 15 times. What did I do wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, anyway, I made a counting error here. 80, 88, 96. Somebody help me here. 88 plus 8, 6, 1, 96. 96 plus 8 is 8. We get 6, 12, 14, 1. We get 104. Okay, I had 114. 104, 112, and then 120. All right? All right, I fixed my error. I knew something was wrong there. So turns out that the three of them have 120. I just divided 8 into 20. 10 goes into 120 12 times, and 12 goes into 120 10 times. So that turns out to be our answer. Right, the answer is 120. So there's a lot of numbers being thrown down here, and there's some room for error, which I just made. I can solve this in my head. I can't solve it on paper. So there's another way to solve this, just so you know it works as a double check, which is to basically create factor trees of each number. And in this case, it doesn't matter which number we pick first. By the way, in this case, it also didn't matter which number we pick first, but using the larger one means we're going to get to that smaller number faster because it's going to grow the fastest. We want each to grow to that. Okay. So let's just take in an order. The factor tree of 8 is 2 and 4, and 4 splits up into 2 and 2, and there's nothing more we can do with that. Okay. What was the next number? Was it 10? 10 is 2 and 5, and there's nothing more we can do with that. We're done with that. And the next number was, what was the next number? 12? It's off my screen at the moment. Let me see here. Yeah, the next number is 12. Actually, let me make sure this is coming on the screen. And 12 is 2 and 6, and 6 is 2 and 3. Let me just make sure that's coming out. This is a synchronization problem. Yeah, this is the more efficient way. That's what I'm showing you now. Let me just make sure this is coming on the screen. It's about a 20-second delay between what I say and what I can see on the screen, and there's probably a 20-second delay with what you see me saying and what's being written down on here. I notice a lot of people doing live streams have this synchronization problem. All right, so what we need to do is, this is 2 times 2 times 2. This one is 2 times 5. And this one is 2 times 2 times 3. So what we need to do is look at each unique thing. There's 3 2s, 1 2, and 2 2s. So we're not going to use these two, and all we're left with is 5 and 3. So we end up with 2 times 2 times 2 times 5 times 3. So we get 2 times 2 is 4. That's 8. This times this is 40, and times this is 120. So it turns out that that's what we know what the number is going to be there. All right? So we can get the least common multiple. This is called prime factorization because the leaves at the bottom always turn out to be prime numbers. All right? So that's a way to do it. I would suggest if you have time to double check numbers to do it both ways because you could make a mistake in here, both when you split up the tree and also when splitting out how to use which factors from which number. Okay? All right, number 1 here, this number 1, it's also basically a grade 7 or a grade 8 question from the state math test. But again, it's trying to show you mastering this. And if you can zoom through a problem like this, especially on the SHSAT, this is obviously a standard ISEE question. It would not be one on the SHSAT. That said, there's a little tiny bit of chicanery going on here. And if you don't have the mastery of the math, you're going to get this one wrong. Okay. All right, let me bring this up on my screen just to make sure you guys can see this. Yes, I believe you're okay. So clothing store, we're going to take a census at a time. A clothing store had shirts on sale at 20% off regular price. The store then took an additional 10% off the sale price. What is the final price of the shirt originally priced at $50? Okay. Yeah, I just did it in my head. I did a rough estimate on my head, and I believe B is the answer. Most kids, or enough kids, are going to do 20 plus 10 equals 30, and then take 30% off. And I think get the answer 60 because 30 out of 50 is 60 out of 100. Okay? Which is probably going to give them C or something like that. That is not the way to do it. Okay? We're going to have $50. We need to take 20% off times 10% off. And what this is going to turn out to be is this is 80%. This is 20% off, and this is 90%. And we're going to figure out our numbers from there. Those are large numbers. We could also take 50, do the 20%. That's $10. Okay. Did I do that right? 150. Yeah, that's $10. So we get $40, and then take 10% off of that, which is going to be $4, and get 36. Or you could go straight up with the larger numbers. Both of these are simple enough. I would suggest not doing it in your head though. These are high stakes tests. You have about a minute or two to solve each question. It's worth writing it down, especially when you want to review it later if you have extra time. All right, so this one I don't want to spend a lot of time on. It's just a no-brainer. When you take 20% off of something and another 10% off, the key here is you're not taking 30% off. You're taking more off. Okay. In fact, they took 28% off of, I believe, or you're taking less off then. Because, all right, so let's skip that one. Okay, this is getting closer to what a SHSAT problem is, and it's absolutely an ISEE problem. So again, if you're watching this for ISEE purposes only, you're getting what you paid for. And the SHSAT people, this is, again, it's key to understand that you have to know all your fundamentals. All right. So let's read through it. To park a car in the Park Anytime garage on a Sunday, the cost is $2 for the first hour, or a fraction thereof. Reading it, when I see something, I go, uh-oh. So fraction thereof, what are they talking about? And 60 cents for each additional hour, or fraction thereof again, thereafter. Which rule represents the total cost, T, of parking a car at this garage for n hours if n is a whole number of hours? So there's a lot of words being thrown around here. All right? Let me make sure this is on your screen okay. Yeah, I believe you guys can see that. So, let me bring up another version. I have to keep swapping back between screens here, between what YouTube is showing and what OBS is showing, and then the actual file I'm actually trying to get through here. So let's take it a sentence at a time. To park a car in the garage on Sunday, the cost is $2 for the first hour. Okay, so if I stay an hour, it costs me $2. Or fraction thereof. So it means if I stay half an hour, it's still going to cost me $2, it sounds like it's saying, for the very first hour. Or 60 cents for each additional hour, or fraction thereof. So again, if I spend 2 hours there, I'm probably doing $2.60, and if I spend 2 hours and 15 minutes, I'm probably doing $2.30. Okay. Which rule represents the cost for n hours if n is a whole number of hours? So since they're talking about whole hours, it seems to me they're throwing away the fraction thereof part. So we're not going to deal with minutes. We're just going to deal strictly with hours. All right. So there's a couple ways to do this again. One is you could cover the answers and try to figure out what the answer is, and you should often do that. Another strategy to solve problems, especially if you don't know how to do, is use brute force. On a problem like this, it's trying to ask you to match some of their answers with what your answer would be. So even if you covered up the answers and came up with something, it may not match exactly what they had. We had an example yesterday where it talked about Jake and Mike's speed, and it was 1,000, and the way you have wrote it may not have been the way they write it, but you have to make it algebraically equivalent. All right? So let's just look through these. So it's $2 for the first hour. and 60 cents for each hour. Well, A is showing that n is applying to the 60 cents, which is the number of hours, but it's 2 times n. But it's not 2 times n, it's only about the first hour. So that's no good, all right? B says it's 60 cents an hour minus $2. No, it's 60 cents an hour plus $2, which is what C is. Okay, so C seems to be the answer, right? 60 cents an hour plus $2 for the first hour. So what the heck is D? Any thoughts of what D might be? So if you're catching this on the replay, you can stop the video at any point, both when I'm ready to give answers or when I ask a question, which lets you ponder on it, things like that. So let's see, B or C. Are you putting C for this answer? I'm not sure what question you're at. So it turns out D is the answer. The reason D is the answer is because the first hour is already taken care of. It's only $2. So the problem with C is that if you stayed for 1 hour, you're going to pay the $2 it says for the first hour and another 60 cents. But if you stay to 1 hour, you're only going to, there's no other time. You're only supposed to pay $2, not $2.60. So what D is saying is the 2 in the D accommodates the first hour. And then since n is the number of hours, we need to take 1 away. So it's 60 cents for each hour after the first hour, right? Because it says 60 cents for each additional whole hour. Additional. If that word additional wasn't there, then it would be C. But in this case, it means the very first hour is $2, so they can give you a higher price. And then if you stay after an hour, it's only 60 cents an hour thereof. All right? So part of this is understanding how to map the English into the algebra. All right? So this is slightly tricky. I believe most people would rule out A or B, and then they would probably go with C. They would just throw D away because it looks too weird. But it turns out intuition is often wrong, and it's worth understanding something like this. And problems come up like this often where you do have to throw away the first iteration of something. Some of you may or may not have learned arithmetic progressions and exponential progressions, and this applies to there. So it's something you need to get used to. Either you know about it or you should know about it. And it's worth figuring it out because, hey, if you're actually going to park in this garage, you need to know how much to pay, or you may not have enough. So we're going to go to question number 2. And 2 is interesting as well because we look at it from a number sense. So 2 is basically just doing the cross product. We'll do that in a second. But let's kind of analyze this a little bit. Let's say you don't know how to use the cross product. How can we solve this from number sense? So we notice that's 9/12, which can be simplified to 3/4, right? And there's something weird going on, which is that the 9 is less than the 12, and yet the symbolic one on the left shows x plus 3 over x. In other words, if x is 1, then that's 4 over 1. Or if x is 2, it's 5 over 2. And in that case, it's top-heavy. The numerator is greater than the denominator. So how could x plus something over x end up being equal to 9/12 if the numerator always has to be larger? But if you kind of sit there and contemplate your navel a little bit more, you'll understand that if x is negative, that you can get a denominator larger than the numerator, or at least the absolute value of it, so that we could eventually map it into 9/12. So once you realize that x might be negative, you can rule out A and B. So let's brute force then C. C says minus 1 plus 3 over minus 1. So that gives 2 over minus 1. That's definitely not equal to 9/12. And let's try D. So we have minus 12 plus 3, which is the same as minus 9 over x, which is minus 12. So we have minus 9 over minus 12, which is equal to 9/12. Because we have minus 1 times 9 over minus 1 times 12. And the minus 1 over minus 1 can cancel out, so we end up getting 9 twelfths equals 9 twelfths. All right, so we can solve this by brute force and by number sense. Right, we applied number sense here twice. One is that we tried to look at the algebraicness compared to the 9 twelfths and decided, oh, this thing needs to be a negative number. And then we just applied the negative numbers to see which ones are there. If they didn't give the answer choices, you could have started using numbers and eventually got to what the number should be. And then the cross product way. Let's do that. And again, I'm giving 2 ways to do a lot of these so that you can double check them. One of the things about double checking something is, for instance, let's say you did the cross product and you do it wrong. Chances are good that you're probably going to do it wrong the second time and get the same wrong answer twice. Okay, so what the heck? So anyway, we get x plus 3 times 12 equals 9x, and this becomes 12x plus 36 equals 9x. We can do this a couple of ways. Let's take 9x from both sides. We get 3x plus 36 equals 0. And then 3x, subtract 36 from side, equals minus 36. And then divide by 3. And we get x equals minus 12. Again, even though we already brute forced it, if you were only using this technique, you would still take the minus 12 and feed it back in. And we just proved that minus 12 works there. All right, so that's that one. By the way, I'm going to go for about an hour. I started at 3:30, so we're halfway in. And then we're going to do other parts other days. Again, this is the sample of the sample. The link to the file I'm using is explained at the bottom of the description to this YouTube. One of the things with the ISEE is, even though there's answers to these, all the other questions are not explained. I'm not sure how to raise the volume, so you're going to have to do that on your side. I'm going to have to try to use a different headset. But let me try this, actually, now that you're saying that. Let me try one thing here. Testing. Did that guy higher or lower? Did that get higher or lower? Maybe you can't even hear me at this point either. Let me try it on the other side of this. Did that get higher? Did that get higher or lower? You're no help. Come on, bro. Did that get higher or lower? And I'm talking right into this microphone. Anybody there? All right, I'm going to continue on, hoping that got better. I raised the decibel level. I lowered the decibel level first, and then I raised it. So let's see if this is any better. So this one really is not a SHSAT question at all. So I'm only going to spend a few seconds on it. In fact, there's only 2 choices here, which is A and B. If you go through each path, what you basically need to do is follow each path A to C and put a tick mark on it. And if anything has 2 tick marks, it's probably not it. And if there's any line with no tick mark, it's probably not either. So it turns out that if you tick mark on A, I believe it was A, that it has all the answers in it. This is just trying to see if you can map things back and forth. There's more convoluted ones that can be created, but in this case, it's unnecessary. All right, so this turns out to be, to me, a very important question. So what is the height of the trapezoid? Let me just see that YouTube is carrying along with me here. Yeah, YouTube is good there. So on the SHSAT, they will not be giving formulas. Okay? So in this case, they did. So there's still something you need to figure out because it talks about B1 and B2 and H, and you still have to understand what those mean. So again, we're getting back to mastery of stuff. And in case you didn't know, the shape is called the trapezoid. I'm hoping everybody taking the ISEE and everybody taking the SHSAT knows that the shape is a trapezoid. So it says, what is the height of the trapezoid if the area is 78 centimeters squared? This is just a matter of plugging in the numbers. So if we have the area equals 1/2 B1 plus B2 times H, the dotted line there that they're showing, that's the H. This is H. This is B1, and this is B2. Okay? So really what we need to do is 1/2. 8 plus 18. Is that the numbers they have? Yes, 18. Times H is going to be equal to the area, and they're telling us that's 78. So we get 8 plus 18 is 26 over 2 times H equals 78. We get 13H equals 78. And what, 550, that's 65, 6, 8, 1, 78. So H is equal to 6. Okay? So here's a good question. And by the way, this is what separates why the SHSAT is important. And this might be a good point where you do pause the video. Does anybody know how to solve this if they didn't give the formula? How do you possibly solve this if they did not give the formula? So think about that a few seconds. We're being given the two bases, and that's all we know. So how can we figure that out from here? So let's draw this over again. Yeah, separate into right triangles. Whereas they already gave us this. We know this is 8. This is 18. Again, we don't know that we got 6 yet. We're still trying to figure out what that is. What we can do is drop down another one. Right? So we know that if we call this x and y, that x plus y is going to be equal to 10. And what Leo is suggesting is that if we fulfill this here, we basically have an 18 by 8 rectangle. Right? So let me see, 18 times 8, 4, 6, so that's 144, right? And we know we're shooting for 78. So what's that? 144 minus 78. Because we're going to take the part we know and subtract off it the two other parts to find out how much area is left. So we're going to get 3, 1, 6, 0, 1. We're going to get 66, I believe. Did I do that right? No, I did that wrong. We're using wrong numbers. What we have is, we know 18 here. And we're trying to get this number here to get the full square footage. So if we take, by the way, did the volume get any better? Because it's worth figuring this out as long as somebody's here live. Let me try to tweak that again. Where is that setting? Did the volume get any louder? I'm not sure he can hear me. Anybody out there? All right, I'm gonna try to move it again, just in case. In fact, when I try to play it back, I'll be able to know it as well. I'm gonna bring it up to 18. I don't know if that helps any. The volume got louder. Did it just get louder again? Because I'm gonna move this away from my mouth now. I've been holding it up to my mouth. Did it just get louder again? The beautiful thing here is technology is great, and we can get some of the things going, but there's also problems where it doesn't pan out. It becomes a nuisance. So